question number 81. Let's read the question. Which of the following is a correct option for free expansion of an ideal gas under adiabatic conditions? Student, here it is given that free expansion of an ideal gas. And as we all know that for free expansion, pressure external is equals to 0. And we know that W is equals to minus P external delta V. Since P external is 0, that means work done will be 0. Also, it is given adiabatic conditions. That means Q is equals to 0. According to first law of thermodynamics, we know that delta U is equals to Q plus W. Since Q and W both are 0, that means delta U is 0. Also, we know delta U is a function of temperature. If delta U is 0, that means delta T is also 0. Now we'll be talking about delta H. We know that delta H is equals to delta U plus P delta V. Since delta U is already 0, we have calculated plus delta N R T. Since a number of moles R and T all are constant, that means delta H is also 0. So the correct answer is option number 3. Moving to the next question, which is 82. 1 mole of an ideal gas at 300 Kelvin and 10 atm is expanded to 1 atm pressure isothermally and reversibly. Then work involved is, student, we all know that for isothermal reversible expansion, work done is equals to minus 2.303 nRT log P1 upon P2. Let's put the values. Minus 2.303, number of moles is 1, multiplied by 8.314, multiplied by temperature, which is 300 Kelvin. First of all, we have to convert the value of R into kilojoules, because we can see that maximum answers are present in kilo. So 10 to the power minus 3 multiplied by temperature, which is 300 log P1. P1 here is 10 and P2 is 1. So 10 upon 1, which is 10, and the value of log 10 is 1. So let's multiply the rest of the digits, which is equal to minus 5.74 kilojoules. Student, I have multiplied the entire thing. You have to multiply this. And again, I'm telling you, please avoid using calculators, because you have to practice more and more so that your calculations will take lesser time. That means the correct answer is option number 1. Moving to next question, which is question number 83. Let's read it. Among the following, which pair of acid and base has highest negative enthalpy of neutralization? Student, we all know that if the neutralization involves a weak acid and a weak base, some heat is utilized to ionize them, so the heat of neutralization will be reduced. So in case of a strong acid and a strong base, the heat of neutralization will be maximum. So it is very clear that in option number 1, the acid and base present both are strong. As a result, we can say that the enthalpy of neutralization will be maximum in case of option number 1. So the correct answer is option number 1. Moving to next question, which is 84. Let's read it. If enthalpies of combustion of glucose, carbon and H2 are minus x kilojoule, minus y kilojoule and minus z kilojoule respectively, then the enthalpy of formation of glucose is. Students, first of all, I'm writing the reactions of enthalpy of combustion of carbon, hydrogen and glucose. So first, let's start with combustion of carbon. Carbon solid plus O2 gaseous gives CO2 gaseous, and here enthalpy of combustion is equals to minus Y kilojoules. Next we have H2, so H2 gaseous plus half O2 gaseous gives H2O liquid. Here enthalpy of combustion is equals to minus Z kilojoules. Next we have glucose, so I'm writing here C6H12O6 solid plus 6 O2 gaseous gives 6 CO2 gaseous plus 6 H2O liquid. And here the enthalpy of combustion is minus X kilojoules. Now student, mark this as 1, this as 2, and this as 3. We have to analyze the enthalpy of formation of glucose. So I'm writing the formula that represents the formation of glucose, which is 6 carbon solid plus 6H2 gaseous plus 3O2 gaseous, which is equals to C6H12O6 solid. We have to calculate the enthalpy of formation for this reaction. And it is very clear that this reaction will be obtained on multiplying the first reaction by 6 and then adding it to the second reaction and also multiplying the second reaction by 6H2. So we have to multiply this. So 6 into the second reaction, and then we have to reverse the third reaction so that this glucose, that is C6H12O6, will move in the product. So we have to subtract the third reaction. So let's calculate. Enthalpy of formation is equals to minus y into 6, then minus z into 6, then the value of the third reaction will be reversed, so it will be plus 6. As a result, enthalpy of formation of glucose will be x minus 6y minus 6z. So the correct answer is option number 1. Here I'm writing answer is option number 1. Moving to next question, which is 85. Let's read it. In an isothermal process, entropy change for 1 mole of substance is expressed in, student, for an isothermal process, entropy change is equals to delta S is equals to R ln V2 by V1. That means the correct answer is option number 4. In option number 1, it will be Q reversible upon temperature. In option number 2, there will be delta S is equals to R ln V2 by V1. In option number 3, it will be delta S is equals to R ln P1 by P2. So that means option number 1, 2 and 3 are incorrect. Only option number 4 is correct. So the correct answer is option number 4. Moving to next question.